multiplexing PCR or ELISA. And whenever possible, we want to be doing all of these, especially when we're working with the Clean Plant Program, where we're developing the plants that are going to be what we call our G1 block, or the starting source for all the raspberries or blackberries of that cultivar that are going to be grown. Those are the ones that get a lot of attention, a lot of testing to make sure they can be virus clean. So in addition to having a graduate student working on the virus component of these complex in red raspberry, there's an entomology student working on understanding she's looking at leafhoppers and aphids in northern Washington where the populations are high. So as we try to fine-tune our control, we need to know when are the aphid flights happening during the year, and how frequently, how close together, and if there's one major flight, can we really control that aphid problem with a single spray? And so, again, raspberry latent virus, if that aphid has to feed for a week before it can transmit the feed, and then can't transmit for 1 week, that gives us a lot of time when we can target control. If it's raspberry latent, raspberry leaf model, which is the claustrovirus, that window is much shorter. It's probably more like 24 hours. So that's where we're really hoping that raspberry latent is a major player here, because based on the biology of the transmission, it's going to be a much easier one to control. So what Danielle is doing is putting out trap plants we have fields with high aphid populations, so we're looking at a grower that is not doing IQF. He's producing juice, raspberry juice, and puree. So he doesn't do it anywhere as near as much vector control as people that are doing IQF, because he's not too concerned about some crumbled fruit. So she's doing trap plants in fields where there's no or very little vector control, and also in fields where they're doing very stringent vector control because they want IQF fruit. So she's putting these out every 2 weeks, and also putting out sticky cards every week. And so we have 2 students in Corvallis. The work is all up in northern Washington. It's a 6-hour drive if traffic is good. But between them, they get up there. We actually now have somebody working up there for us, but they're up there every 2 weeks during the growing season. So a lot of I-5 time. And so what we're hoping to do is, this is some work that was done in our lab with black raspberry necrosis virus, another virus in raspberry that we see in the Northwest, much more in Oregon than we do up north. I don't know why. But in this case, Annie Hallgren, the student, was looking at aphid populations in 3 different fields, and she did this for 3 years, and it usually peaked. The peak flight was always right around the middle of June. So if we have a similar type situation, and if we can do a well-targeted spray at this point, would we be able to control the aphids to the point where we get relatively little virus transmission if we're controlling raspberry latent, and that's all we need to control? If raspberry leaf model and bushy dwarf together really don't impact fruit, we don't care if they're there. From the grower's point of view, they're not worried about virus, they're worried about disease. So let's identify that weakest link, and that's where we want to put our efforts. So she's looking at the aphid population, this similar type thing, looking at aphid numbers throughout the growing season, but also when the eggs hatch in spring. So she's out there right now trying to determine when eggs hatch, because when those eggs hatch, when those aphids become adults and they're winged, they're going to migrate. That's the initial migration, the initial flight. So when is that happening? Because it might be that we control the aphid in the perimeter of the field before they fly. So she's looking at several different strategies. What's the best way to target that aphid flight to minimize virus movement into the fields? And then if raspberry latent is our major one, then even if the aphid flight started here, we could wait 6 days before we had a target, and hopefully the major flight is finished. And this is, again, looking at the black raspberry necrosis one. So this is the average number of aphids, and these are virus infection in our trap plants that were out in the field for 2 weeks, out there for 2 weeks, bring them back. So we can see we had our peak infection before we had our peak flight, which is a little bit surprising. But again, we realize we need to be looking at control back at this stage. Is there hope for control? Sure. The biggest thing is start with virus-tested plants. If you look at that field, those plots they put in, those healthy plants got off to a good start. So they're going to have a respectable crop that first season. And it's going to take multiple years for them to become infected, so that even if that field's only in 5 years, you're going to have a much better profit margin than if you start with plants that have virus. So getting a good start is really important. Identify the vectors. Know what the vectors are in your area for the major viruses, their biology, when they're moving, what time of the year that first flight is. During the year, is there a peak flight sometime mid-season? Normally what we see at the strawberry aphid and the raspberry aphid in our area, we get an early season flight and a late season flight. That early season flight when they're coming into the field, that late season when they're getting ready for winter, going someplace to lay eggs. But know what the vectors is and when their major flight is. That's really critical. Determine which viruses are important for disease. Again, if raspberry latent virus is required, without that we don't get disease, that's going to be our target. If it's raspberry leaf mottle, that's the one you have to target. So identify that weakest link. For a fruit grower, you don't care if the plants are infected as long as they have a nice crop. Plants may have some viruses with minimal or no impact. And again, that fruit grower, they just want to have crop. And in raspberry and strawberry and blackberry and a lot of these perennial crops, really looks like we need virus complexes to cause a disease. Not in all cases, but in many cases, it's a virus complex that's causing that disease. And so we have some wiggle room in that we don't need to control everything. For the nursery, we want to control everything so that the plant going into the field is clean. And if we're growing a plant in Washington, it's clean, and it's coming down to Arkansas, we're not introducing a new virus here. So the nurseries, I think it's critical that they be as clean as possible. But it's a much smaller acreage, so it's less pesticides, and it's not a food crop at that point. So it's a different strategy. And think long term. We have nematode-transmitted viruses. Do you have vectors there? Do you have inoculum? Is there an abandoned raspberry field next to yours? If there is, there's a good chance they've got some of the aphid viruses. So look at the potential risk of a site. And if you can be isolated, that's the best thing you can do. And again, start with clean plants. That can't be overstressed. If you see a problem, figure out what it is. If it's nematodes and you're spraying for aphids, it's not going to be any good. And get on top of control as soon as possible. Because these, especially the aerial vectors, those are moving really fast. And know which are the critical viruses in your area. You know, for blackberry here and blackberry in North Carolina, the virus complexes are different. You may have a different critical virus that you're trying to control. Raspberry viruses for us are different than what they have in the Northeast. So the one-size-fits-all is not going to work. You need to know something about your vector, the disease pressure, and the environment before you can implement an effective strategy. You know, this is a great tabletop cooler in Wisconsin. It's probably less effective here. Or at least. Yeah, but in Wisconsin, this is good at least 6 months of the year. No, this wasn't in June. So, you know, we have a lot of viruses in rubus, and these in red are really the major ones we're worried about in raspberry. And you can see there's that's due to change. The major ones in blackberry, you can see there's a lot more yet to be determined. That gives us some flexibility here. And then the green ones are maybe not are minor viruses or not in North America. These are nematode transmitted. These are the two major ones here in North America. But the thing is, in blackberry, we don't know what a lot of the vectors are yet. And we're still learning some of that in raspberries, but I think we've got fewer to work with, so we're in a better situation. Diagnostics, maybe I'm old school, but if I can do ELISA, that's what I'm going to do. It's fast, reliable, can be automated. I can get an undergrad to come in and do that pretty reliably. PCR is more sensitive, but less.
When we took that mice to send out good now, I need other guys instead of grass.
No. No, what I'm saying is the undergrad is cheaper to hire. We're looking at effectiveness at dollars per hour. The problem here is that for all these recently discovered viruses, it's all based on nucleic acid. We haven't purified the viruses and made antibodies. So for many of these, we don't have antibodies. PCR is more sensitive, and the extraction is much more involved, a little trickier, handling RNA. You have to be a lot more careful. It's more expensive to run the assays, but all of the viruses that we're dealing with, we have PCR. We can do PCR. Grafting is the gold standard. But as I showed you, there's some that aren't showing symptoms. Blackberry yellow vein doesn't show symptoms in our indicator. And really, it's only being used when we're looking at that top tier of the certification program, because it's a very expensive proposition to do the grafting, and it can take a lot of time. And that's just a reminder to me that not all things are caused by viruses. We got 3 blocks of Pinot Noir here. This is the only one that we did not find any virus. And I diagnosed this one from the highway. This was grapevine leaf roll virus on a rootstock probably. You can see some spread here. Went in and tested. This was negative for everything we tested. This had Rhopestra stem pitting. This had stem pitting. And these red ones here have been girdled by voles. Bad guess. And we also do a virus elimination program. So the breeders, including John Clark here, a number of other breeders, all the breeders in the Northwest, some others, send us material. We go through all the testing. If we find virus, it goes into eradication. It goes through that treatment. We test lab and graft indexing. If it's positive, it goes back to this stage. If it's negative, it goes into our top tier of that certification scheme, which we call G1 or Generation 1. It's propagated from there, it'll be Generation 2, trying to simplify the terminology. And these are made available then to industry. And the entire collection is retested again every time we find a new virus or on a regular basis. And I'd like to thank check writers, all the berry commissions, Oregon, Washington, British Columbia, the Southern Regional Small Fruit Consortium, North American Raspberry Blackberry Association, individual farmers. The individual farmers, we're doing the transgenic plants. We had a grower that let us use 6 acres of raspberries. 6 acres for 6 years. They did all the work. They managed it, they pruned it, they fertilized it, and they didn't charge us a penny. In an SCRI project, that would be $250,000 of in-kind contributions. So that's really huge. Ag Research Foundation at Oregon State is a nonprofit. Whatever they make at the end of the year, they put into a grant program. We've got a number of grants from them. USDA pays my salary and a couple of other salaries in my lab. The Specialty Crops Research Initiative, we have one on rubus with Yanis and other people. We have one on grapes. That's recently been a huge influx of funding for us. And the National Clean Plant Network, very beneficial. And the workers, technicians in my lab. Danielle is the entomology student currently working on the project, other graduate student. Yanis was up there and he moved down here. Paycheck-wise, that was a big improvement for him. Collaborators in various locations. So with that, you might ask what I do if all those people work. Well, somebody's got to do the quality control. That's my job. I get to do the fun stuff. I get to growers' fields, travel, give talks, the not-so-fun stuff, especially this one right here. And so basically life is good in Corvallis. And with that, if there are any questions, I will try to answer them.